All right, next section of the lab report is the results section. All right, so once again, we'll start by talking about the purpose of this. This one's going to focus specifically on graphs, but I am going to talk about results in general. So we want to display the results, display the point of the lab graphically. Okay, and the other thing the results section does is it provides evidence for writing the conclusion. So really, this is where you're doing the legwork. This is where you're doing the hard work that's going to set up for being able to write your conclusion and analysis. So there's a few different techniques for analyzing the data that we're going to use. This one we're going to go over basic graphs, but we also have some other ways that we'll go over in subsequent videos. So graphs are a great visual way to display results, all right? On its most basic level, you can see how one variable changes as the other. Does it go up? Does it go down? Or does it really not have a change? So the one thing a graph does is show a consistent change, okay? And show what that basic relationship is between those two variables. We also can use graphs to verify a mathematical relationship. That's not something we're going to do right now, but later on in the year, we're going to look at how we can get a little bit more specific than when one increases, the other increases, or when one increases, the other decreases. But for now, that's pretty good. So, what should a graph have? Every single graph should have a title. And the way we usually write this title is the standard format is y versus x. So whatever variable is on the y-axis versus whatever variable is on the x-axis. So distance traveled versus launch velocity, for example. That's going to be how we're typically going to write the title. We also need axes titles with units. So every axis should have a title on it, and it should have the units in parentheses. And we talked about that before. All right. When we do tables, we put the units in parentheses as well. We should always have a best fit line. It may be linear, it may not be, but it's important that we do have a best fit line or line of best fit, whatever you want to call it, added to the graph, as well as an equation for that line and an r-squared value. Now that might be something that you're not familiar with, or maybe you are, but the r-squared value is a statistical measure of how accurately that best fit line matches with the data. We're not going to get into any more specifics than that. That's all you really need to know for now for this class, but it's a measure of how accurately the data matches our best fit line. And an r-squared of 1 is a perfect fit. So if you get like 0.98 or 0.99, that's extremely, extremely good. Because realistically, you're never going to get a perfect fit. One quick note here. Again, this is a convention, a stylistic thing, but typically the x-axis is the independent variable, the thing that you physically changed, and the y-axis is the dependent variable. The other thing is, if you conducted multiple trials, you should always graph the average value. And one last thing that I don't actually think is in your notes, but I'll add here, is don't use a polynomial fit. All right, I'm not going to get into all the specifics there, but basically the polynomial fit is always going to look like a good fit, but rarely is it the correct fit. Usually it's going to be linear or exponential or a power. So here we have an example of a graph. You see we have the title here, the y-axis versus the x-axis. We have both axes labeled with the quantity that's on that axis, as well as the units in parentheses. We have our data points here with a best fit line, and we have an equation with an r-squared value. The specifics of how exactly to make this graph on Excel are in another video, so if you're not super savvy with Excel and could use a little help there, that's a great resource. So as we look at this graph, as we think about the analysis section, there are a few things that we want to ask ourselves that's going to come back and help us in the analysis section. So the first thing is, what does the graph show about the relationship between the two variables? And that's as simple as one increases, the other increases, or as one increases, there's really no change. All right. Second thing to think about is what is the meaning of the slope. Okay, so if we're looking at a specific graph, we could say, as the mass of the car increases by 1 kilogram, the launch velocity decreases by 0.5 meters per second, or whatever that slope was in the previous one. So really it tells us how much y changes when x changes. That's what the slope tells us. So we can use that to get a little bit more specific in our analysis. That's assuming it's linear, which again, it might not always be linear. What is the meaning of the y-intercept? Well, the y-intercept is really going to tell us what the value is for y when x is 0. So sometimes that's a meaningful thing. Not always, but sometimes that's a meaningful thing. And along the same lines, should 0, 0 be a point? Okay. In some graphs, 0, 0 will be a point, and logically it makes sense that it's a point. In other graphs, that's not going to be the case. But that's something that you can comment on in the analysis section, is whether or not it was a point and whether or not it should be a point. If that's an appropriate thing to comment on. It all depends on the specific graph that you have.